9:14 a.m. A research vessel somewhere in the Amundsen Sea, West Antarctica. The temperature outside is minus 22 degrees Celsius. Dr. Rob Larter, a marine geophysicist with the British Antarctic Survey, is staring at a satellite image on a laptop screen. The image was taken 48 hours ago by the Cosmo SkyMed constellation, a cluster of Italian radar satellites orbiting 619 kilometers above Earth. What the image shows has stopped everyone in the room cold, not from the temperature. From what it means? Because the crack they've been watching for 2 years has moved again, and this time it hasn't just moved, it's accelerated. And there is something hidden in this story, a detail buried inside the latest data that the headlines have not caught up with yet, that changes the entire timeline. We'll get to it. But first, you need to understand exactly what we're losing, and why losing it changes the planet you live on. The glacier is called Thwaites. Scientists call it the Doomsday Glacier. That is not a media nickname invented for clicks. That is what climate researchers, sober, conservative, peer-reviewed researchers, actually call it in briefings. Thwaites Glacier sits in West Antarctica, draining into the Amundsen Sea. It is 75 miles wide. In places, it is 2,000 meters thick, over a mile of solid ice stacked on top of itself. Its total basin covers 192,000 square kilometers, bigger than the state of Florida, and right now it is moving. Not in the slow geological way glaciers have always moved. It is accelerating. And the structure that has been slowing it down. The last natural break standing between Thwaites and the open ocean is breaking apart. Here is the specific number that matters. The Thwaites. Eastern ice shelf, the floating extension of ice at the glacier's front that acts as a physical buttress, a cork in a bottle slowing the entire mass behind it from sliding into the sea, has increased its flow speed by more than threefold since January 2020, from a little over 600 meters per year to just over 2,000 meters per year as of January 2026. Threefold in 6 years. And in that same period, the glacier ice behind the shelf, the ice the shelf is supposed to be holding back, sped up by roughly 33%, a third faster. That is what Rob Larter's team is reporting in an upcoming study, and Larter himself, speaking to Live Science in May 2026, did not mince words. He said, "The last bit of ice shelf in front of the glacier is poised to disintegrate. We don't know quite how this ice shelf is going to break up, but it's definitely going to go. Definitely. Going to go." Signal number one, this is no longer a might happen conversation. We have passed that threshold. The question being debated in the scientific community right now is not whether the Thwaites eastern ice shelf will break apart. It is when. And the most current data published in Science Advances, Volume Burn 12, Issue 19, May 8th, 2026, delivers a finding that should have stopped every major government on the planet cold. The paper is Loss in Southern Ocean Destratification. Its conclusion, the ocean around Antarctica has undergone a fundamental shift. Heat that had been trapped in the deep ocean, held in place for decades by cold surface water, is rising. The thermal stratification that kept warm circumpolar deep water away from the ice shelves is weakening. And as that warm water, just a few degrees above freezing, which sounds small until you realize that a few degrees applied continuously to the underside of a mile-thick ice mass for decades is what has already caused everything we are now watching. As that warm water floods deeper and deeper into the subglacial cavities beneath Thwaites, the melt rate is not linear. It is accelerating. In some channels beneath the glacier's grounding line, the critical boundary where the ice stops resting on bedrock and starts floating, melt rates have been recorded at up to 250 meters of ice per year. Per year. That is not erosion. That is a blowtorch. The IceFin robot knows this better than anyone. IceFin is a torpedo-shaped autonomous underwater vehicle deployed by the International Thwaites Glacier Collaboration, a joint US-UK scientific program involving over 100 researchers from institutions, including the British Antarctic Survey, Columbia University, and the University of Colorado. IceFin was threaded through a borehole drilled through the Thwaites ice shelf and sent down into the subshelf cavity in 2022. What it found fundamentally changed the scientific understanding of how this glacier is dying. It found warm water, 2 degrees Celsius above freezing, flowing directly along sloped ice surfaces near the grounding line. It found that the melting wasn't happening evenly. It was happening in concentrated bursts along steep ice faces, inside crevasses, in the exact architectural weak points of the shelf. The ice is not melting from the bottom up in a uniform sheet. It is being undermined from its most vulnerable angles simultaneously. That is not a system approaching a collapse. That is a system already in collapse, just in slow motion. But here is the catch. And this pivot changes everything you thought you knew about the timeline. Scientists have consistently said the full collapse of Thwaites Glacier would take centuries, not decades, centuries. And that is still technically true for the complete loss of the entire glacier. But the ice shelf, the buttress, the break, the cork, is not going to take centuries to fail. It could fail this year. Rob Larter, the same marine geophysicist, compared the timing challenge to forecasting an earthquake. Researchers can see the strain building, he told CBS News, but they cannot predict the precise moment the system will give way. The Thwaites Eastern Ice Shelf, according to the British Antarctic Survey's own projections, could begin breaking apart as early as 2026, as early as now. Satellite imagery is already showing widening cracks near its anchoring points. The underwater ridges and seamounts its ice is attached to, and along the grounding line itself. The shelf's connection to the seafloor is failing, and a comprehensive 30-year grounding line retreat study published in the Proceedings of the National Academy of Sciences, the most comprehensive record ever assembled, found that Antarctica lost approximately 12,800 square kilometers of a grounded ice between 1996 and 2025. That is almost half the size of Belgium. Gone. Grounded ice that is now either floating or water. Here's what nobody is telling you about what happens the moment the ice shelf goes. Not when the glacier collapses, the moment the shelf goes. Because that moment, which could happen in a single Antarctic winter season, removes the last physical constraint on the glacier's flow rate. Currently, Thwaites is already contributing to approximately 4% of all global sea level rise. That is its baseline rate right now, today, before the shelf breaks. The moment the shelf detaches, the glacier behind it accelerates. The ice that has been piling up against the shelf, held back like water behind a dam, begins flowing freely toward the Amundsen Sea. How fast? The Penis Grounding Line Retreat Study found that in a historical pulse observed in geological seafloor data, the Thwaites grounding zone retreated at a rate of over 2.1 kilometers per year, twice the fastest satellite observed rate. The geology tells us this system can move faster than our models predict, and it has done it before. Now comes the domino, and the domino is what makes this not a story about a glacier. It is a story about every coastal city on Earth. Thwaites is not just a glacier, it is the keystone of the West Antarctic ice sheet. The ice sheet behind Thwaites, the ice that Thwaites is currently buttressing, holding in place, represents enough water, if it all entered the ocean, to raise global sea levels by 10.8 feet. That is 3.3 meters. 3.3 meters. According to the British Antarctic Survey's own published estimates. And this is where the geophysical domino effect begins, because Thwaites is not simply melting in isolation. Its retreat exposes increasingly tall, unstable ice cliffs behind it. Scientists call the resulting mechanism marine ice cliff instability, MICE. The concept is straightforward and terrifying. As Thwaites retreats and loses its ice shelf, the newly exposed ice faces, some hundreds of meters tall, are too large to be structurally stable. They calve, they collapse. They expose the next section of ice cliff behind them, which also collapses, which exposes the next section. A row of dominoes, each one bigger than the last, each one collapsing into the Southern Ocean and raising global sea levels with every fall. Here is what 3.3 meters of sea level rise does to the world you recognize. Miami ceases to exist in any recognizable form. Not the beachfront properties, the entire southern half of Florida. NOAA's own projection maps, updated and published this year, show that a 10-foot sea level rise eliminates the Everglades, submerges the Florida Keys, and pushes the sea to within miles of Orlando. New York City's Lower Manhattan, Wall Street, the financial district, much of the subway system, begins flooding at 1 meter of rise. At 3.3 meters, it is a permanent coastal wetland. Shanghai, with a population of 26 million people, sits on a river delta that is already among the most flood-vulnerable urban environments on Earth. At 3.3 meters, its current flood management infrastructure IS irrelevant. Mumbai, Bangkok, population 11.4 million, sitting almost exactly at sea level, largely inundated. The entire coastline of Bangladesh, home to 170 million people, already lose territory to current sea level rise measured in centimeters. Simply gone. Submerged. Erased from the map. 230 million people currently live on land less than 1 meter above high tide lines. Not 1 meter below, 1 meter above. These are people one major storm surge away from catastrophic flooding even before Thwaites loses its shelf. And that number does not include the hundreds of millions living within the flood zones that a 3.3 meter rise would create. But here's the catch, the second pivot. And this one is about a choice, not a fate. The collapse of the West Antarctic ice sheet, the full 3.3 meter scenario, is not inevitable on any human timescale if the rate of ocean warming can be slowed. The 2026 Science Advances study on Southern Ocean distratification is not a death sentence. It is a warning. It is saying the mechanism is active now, the heat is rising now, the stratification is breaking down now. And if the global temperature trajectory continues on its current path, this process becomes self-reinforcing and irreversible within decades, not centuries, decades. But if emissions trajectories change meaningfully and ocean temperatures stop rising, the rate of warm water intrusion into the subshelf cavities slows. The melt rate slows. The shelf may still ultimately fail. Thwaites is probably, in Dr. Ted Scambos' word, doomed. But the ice sheet behind it, the 3.3 meter scenario, is not yet locked in. It sits in a narrow window of possibility that is closing at a measurable rate, and which science can still quantify precisely enough to say there is still a choice here. Not a comfortable choice, not an easy one, but a choice. Here is what makes that choice harder right now than at any previous moment in modern history. The scientific warning system that is supposed to translate data like this into policy action has been structurally weakened at precisely the moment it is most needed. NOAA's research budget, the agency whose satellite data tracks Arctic and Antarctic ice extent in real time, has faced significant institutional disruption in 2025 and 2026, the same period in which the Thwaites data has become more alarming than any previous measurement cycle. The United States, historically the largest contributor to the international Thwaites Glacier collaboration, has seen its participation in joint climate research programs complicated by policy shifts at the federal level. The scientists doing this work, people like Rob Larder at the British Antarctic Survey, like Ted Scambos at the University of Colorado, like Julia Wellner at the University of Houston, whose team analyzed the marine sediment cores that revealed Thwaites' retreat began in the 1940s, likely triggered by a powerful L. Their work. They are publishing, they are speaking, the data pipeline is still running, but the policy pipeline that is supposed to receive that data and translate it into coordinated international action is stuttering. And that is the third person in this story, not a diplomat, not a general. The third person is you, the audience, because the chain from satellite image to scientific paper to policy decision to emissions, reduction to ocean temperature, stabilization to ice shelf survival does not complete itself without public pressure at scale. It never has. The Montreal Protocol, the 1987 international treaty that successfully closed the hole in the ozone layer and is today considered the single most successful act of coordinated global environmental policy in human history, was not the product of spontaneous governmental wisdom. It was the product of public understanding, sustained media attention, and consequential political pressure applied over years. The science on Thwaites is now where the ozone science was in 1985. The mechanism is understood, the trajectory is documented, the window for action is open but closing. What does not yet exist, at anywhere near the required scale, is the political will. Here is what the next decade looks like in binary terms, because this story, like every story about a system approaching a threshold, ends in one of two places. Scenario 1, the Thwaites eastern ice shelf fractures this year, 2026, or in 2027, it calves into the Amundsen Sea in a series of dramatic events captured by satellite and broadcast to the world. The glacier behind it accelerates. Sea level rise, currently ticking upward at approximately 3.6 millimeters per year globally, begins to climb faster. Not catastrophically in any single season, but measurably, irreversibly faster. The 230 million people living within 1 meter of high tide begin to experience more frequent flooding events that their current infrastructure cannot absorb. Insurance markets in coastal Florida, coastal Louisiana, coastal Bangladesh begin collapsing. Property values in Miami's flood zones already under pressure enter freefall. The economic signal becomes loud enough that governments cannot ignore it. They act. Perhaps too late to save the shelf, but not too late to stabilize the ice sheet behind it. Perhaps. Scenario 2. The ice shelf fails. The political response remains fragmented. Emissions trajectories continue on their current path. The warm circumpolar deep water continues rising. The grounding line retreats further and faster. The dominoes begin to fall in West Antarctica in a sequence that no human infrastructure is designed to manage. Not in a day, not in a year, but in decades that arrive faster than any coastal city's planning horizon, and which carry consequences that make every other crisis of the 21st century, every war, every recession, every pandemic, look like a prologue to the main event. The data from West Antarctica this July morning is unambiguous. The crack is growing, the flow speed is tripled, the ocean heat is rising, the shelf is going. Rob Larder said it, Ted Scambos said it. Over 100 scientists in the International Thwaites Glacier collaboration have been saying it for 6 years. The glacier, the size of Florida, 2,000 meters thick, the keystone of the West Antarctic ice sheet, is losing its last natural break. And the moment that break is gone, the physics don't ask for permission. The only question that matters on July 17th, 2026, is whether the people on the other side of the satellite images are listening. Because the glacier isn't waiting for an answer.